right, thanks, John, for having me. Well, Denise, I will see your disrupting paradigm and raise you a DevOps for the IoT. So I'll spend 5 minutes or so trying to recover and trying to earn your forgiveness for including that tagline. But the point is, for IoT to be successful, for the Internet of Things to be successful, we all collectively need to solve the software problem. And without that, it will be a piling heap. And I'll explain what I mean. So the moment that a car leaves the factory show floor, the moment that devices escape the data center, things change dramatically. And the costs of failure, among other things, go up dramatically. And success is determined by the quality of the software that's running. It's also determined by the security of the software that's running. And you can just ask Chrysler or a number of other folks what the consequences of that might look like. And it's not just modern vehicles that are running millions of lines of code. It is everywhere. And as devices get further and further away, as we generate more and more data, software itself needs to move out to the edge. We place more and more decision-making capabilities onto the devices themselves, right? Whether you want to call this fog or edge or whatever buzzword you want to attach to it, it's happening. So the 4 pictures that you see here are companies that Resin works with today, amongst many others, that are doing very, very interesting, complex things with software running far away. We've got a company off the coast of Australia that has tidal turbines, which will, as the tide goes in and out, they have algorithms that run that will change the pitch and the yaw of the blades to generate energy most effectively. We've got autonomous underwater drones. We've got oil well rigs that will shut off when they run out of gas automatically and prevent dry pumping, which is something I learned about recently. We have the largest property owner in the city of New York that pulls data out of millions and millions of square feet of industrial lighting and HVAC and security systems to run analytics and instantiate change out on the services they run to save tremendous amounts of money and reduce carbon footprint. So the value of becoming a little more modern and a little more capable with how you build, deploy, and manage software is actually more impactful outside the data center than within. And if we're going to be successful with these billions of devices and the increasing amounts of software and complexity, we're going to have to do so without embedded developers. So today, for one of these projects to be successful, you need someone who can write board support packages, who can write device drivers and get really, really close to the metal. And we've got a few 100,000 of those folks out in the world today. The trick will be, can we build tools and technology that allows, let's call them mainstream developers, to be successful, get to market, scale, and provide value to their customers? And that's what Resin does. In one form, we are Git push for hardware. You send your code to us, we'll build, deploy, and run it out on devices far, far away, with high cost of failure, with resource constraints, and we will make you successful. What it looks like at a technology level is actually, at this level, it's quite similar to a lot of what you have probably seen in other presentations. This may be on whiteboards in your offices. It looks at this level like a standard CI/CD pipeline. More interestingly, what we've done is we've tuned it for the unique needs of IoT. So the thought experiment to run in your mind is, how is an AWS instance different than, let's say, the control servers on the tidal turbines that I mentioned earlier? Well, the control servers on a tidal turbine is far away. It's running a potentially diverse set of chipset architectures, right? This is not a homogeneous set of x86 servers lined up in a rack. It's on spotty connectivity. And if you push bad code and brick it, you're not getting it back, right? There's no API call that's going to save you if you brick a device out in the field. So what we do is provide a service that, without intervention from a developer, if not necessary, to allow you to build for multiple different chipset architectures, deploy in a lightweight fashion. We've got customers that push code over 2G networks in rural India and Africa, and then run on devices that are resource constrained. What it looks like on the actual device is sort of an unholy marriage of cloud technologies and embedded technologies. So until Resin came around a few years ago, you never would have seen the Yocto Linux project sitting alongside the Docker container engine. Docker, as a side note, is completely wasted on the data center. And that's a separate conversation if anyone wants to chat on that. Above that, we run Linux containers. So anything you can do in a Linux container, you can do with Resin. We've got a tremendous amount of pickup in a relatively short period of time, everything from smart locks to skyscrapers and everything in between. The point remains, they're all pushing code, they're all running more and more complex scenarios further away, and they have a management gap. Great set of partners, supportive investors, and the whole bit. Developers love us. I think my favorite one is, what a wonderful time to be alive. So join me in the future, sign up for Resin, grab a device we run on, a Pi, a BeagleBone, an Intel Edison, a NUC, sign up, give me your lunch break, and push code to devices. Thank you.